For thousands of years, humans saw nature's limits and quietly stepped over them. The mule, a sterile hybrid with unmatched strength, was just the beginning. Today, every wild bison carries domestic genes, and some hybrids exist only in laboratories or in captivity. The rules we broke shaped life itself, but at what cost? And which of these creatures should never have existed at all? A mule stands as living proof that humans could bend nature to serve their needs. By pairing a male donkey carrying 62 chromosomes with a female horse which has 64, breeders produced an animal with 63 chromosomes, a number that almost always means sterility. Yet for centuries, this trade-off was not only accepted but embraced. Mules offered a rare combination of endurance, strength, and sure-footedness. They could haul heavy loads over rocky terrain, thrive on less food and water than horses, and work longer days without faltering. Ancient farmers and traders recognized these advantages early. Egyptian art from 1400 BC already showed mules pulling carts and plows. In the United States, the story took a decisive turn in the 1780s. George Washington, seeking to modernize American agriculture, persuaded King Charles III of Spain to send a prized jack donkey named Royal Gift. Washington bred his mares with these imported donkeys, and he distributed the offspring to farmers across the young nation. By 1808, the United States mule population had soared to over 850,000 animals, each a product of intentional crossbreeding and each unable to reproduce. The sterility of the mule was not a flaw, but a calculated cost. Breeders knew every generation would require another deliberate cross, but the rewards, reliability, resilience, and sheer labor power outweighed the inconvenience. For those early breeders, the mule was not just a beast of burden. It was a tool of progress, a testament to the idea that sometimes breaking nature's rules could build a nation. Beefalo were born from a drive to engineer animals that could outperform nature's own designs. In the early 1970s, breeders set out to combine the hardiness of American bison with the productivity of domestic cattle. The goal was clear: create livestock that could survive harsh climates, resist disease, and produce leaner meat. The result was a hybrid, 3/8 bison and 5/8 cattle, marketed as the best of both worlds. But the story of beefalo is more complicated beneath the surface. Early attempts to cross bison and cattle, dating back to the 1800s, were plagued by infertility and unpredictable traits. Only with modern breeding techniques did the hybrid become viable on a commercial scale. Yet even as beefalo herds grew, a new problem began to unfold, one that reached far beyond the ranch fence. Recent whole genome studies have revealed that every wild bison herd tested in North America now carries traces of domestic cattle DNA. This genetic introgression is a direct legacy of the era when ranchers, facing a bison population crash, introduced cattle genes to boost numbers and resilience. What started as a quest for efficiency left a permanent genetic mark on a species once considered a symbol of the untamed West. Conservation geneticists now face a dilemma. While beefalo may thrive on the farm, the spread of domestic alleles into wild bison herds raises questions about what is truly wild. The pursuit of efficiency created an ecological debt, one that cannot be repaid by simply turning back the clock. Breeding for better meat and hardier stock has, in the end, blurred the lines between wild and domestic, leaving no herd untouched. In 1986, a breeder named Judy Frank paired an African serval with a domestic cat in Pennsylvania, producing a kitten that would become the foundation of the Savannah cat breed. The appeal was immediate: a house cat with the spotted coat, long legs, and the wild presence of its African ancestor. Early generations, especially F1 and F2, retained much of the serval's unpredictable nature, leaping onto cabinets, hissing, and showing little interest in behaving like a pet. Demand for these striking hybrids surged through the 1990s and the 2000s, driven by a market hungry for novelty and status. As savanna cats entered more homes, problems followed. Animal welfare groups and veterinarians raised alarms about aggression, stress, and the risk to native wildlife if these cats escaped. By the early 2000s, more than 10 U.S. states, including New York, Massachusetts, and Georgia, had banned or tightly regulated savanna cats, especially first- and second-generation animals. The desire for something wild had crossed a line, forcing lawmakers to step in where nature once set the boundaries. In a laboratory on the outskirts of Dubai, a team of reproductive scientists set out to do what nature never could. Their goal was to cross a dromedary camel with a llama, two animals separated by more than 20 million years of evolution. The challenge was not just biological, but technical. Camels and llamas differ in size, chromosome structure, and reproductive cycles. Natural mating was impossible. Researchers turned to artificial insemination, using specialized equipment and precise timing to bridge the gap. In 1998, after months of trial and error, the first Kama calf was born at the Camel Reproduction Center. This animal carried the strength and size of its camel father, but the temperament and woolly coat of its llama mother. Unlike earlier hybrids created for work or novelty, the Kama was the result of deliberate design, a living proof that technology could erase boundaries that once seemed absolute. The birth of the Kama signaled a new era, where the limits of biology are no longer set by nature alone. Inside the gates of private zoos and roadside attractions, the liger stands as a spectacle born from human ambition. This hybrid, produced by breeding a male lion with a female tiger, cannot exist in the wild. In captivity, male ligers often grow to more than 400 kilograms, far surpassing the size of either parent. The cause is a genetic mismatch, the absence of growth-limiting genes that would normally keep their size in check. This extraordinary growth comes at a steep price. Ligers suffer from frequent skeletal and joint problems, struggling to support their own weight. Veterinary records document severe hip dysplasia, spinal curvature, and chronic pain. Organ strain is common, with enlarged hearts and kidneys failing under the pressure of oversized bodies. Most are sterile, unable to reproduce, and many die young. Animal welfare advocates warn that breeding ligers for novelty or entertainment ignores the suffering these animals endure. Their existence is a stark reminder that breaking nature's boundaries for spectacle often leaves the animal to bear the cost. Across the northeastern United States and southern Canada, a new kind of canid has taken hold, one that owes its existence to the reshaping of forests, farmland, and suburbs. The coywolf carries genes from coyotes, eastern wolves, and even domestic dogs, a genetic blend confirmed by DNA studies showing as much as 60% wolf ancestry in some individuals. Larger and more muscular than typical coyotes, these hybrids can weigh up to 55 pounds, giving them the strength to hunt deer and the agility to thrive in city parks or vacant lots. Sightings in urban areas have increased sharply since 2000 as adaptable packs slip through neighborhoods, feeding on rodents, garbage, and the occasional stray pet. Wildlife managers now face a dilemma because traditional policies do not fit a creature that blurs the line between wild and urban, predator and scavenger. Some regions debate whether to classify coy wolves as pests, protected species, or something entirely new. The result is a patchwork of rules, with confusion spreading as quickly as the animals themselves. What began as a response to habitat loss and hunting pressure has produced a hybrid that thrives in the world humans built, leaving experts to question who, if anyone, is truly in control. In the high Arctic, the boundary between polar bears and grizzlies once seemed absolute. But as summer sea ice shrinks, falling nearly 13% per decade since 1979, those lines have begun to blur. In 2006, a hunter named Jim Martell traveled to Sax Harbor in Canada's Northwest Territories. Expecting to find a polar bear, he instead shot an animal with creamy fur and a distinct shoulder hump. DNA analysis by the Canadian Wildlife Service confirmed what scientists had only suspected. This was the first wild grizzly bear ever recorded. Grizzly bears, forced north by warming temperatures, now share territory with polar bears searching for stable ice. The overlap brings more than chance encounters. It brings the birth of hybrids that would never exist without the rapid changes in their environment. Arctic researchers now track these hybrids as living indicators of a world out of balance. Each grizzly bear is both a symptom and a warning. It is proof that climate change is not a distant threat, but a force rewriting the rules of life at the top of the world. Every living hybrid is proof. Nature's boundaries are not suggestions, they are warnings. As climate change and genetic technology accelerate, the line between creation and consequence blurs further. What we invent now shapes tomorrow's wild. The question is no longer what we can make, but what we should allow to exist.